In this question, we have y is equal to cos x into cos 2x into cos 3x. So we have three different functions in multiplication. So we can consider this as a form 1. We already assume y is equal to our function. So let's take log on both sides. So on left side we will get log y, and on right hand side we will get log of cos x into cos 2x into cos 3x. Before we go for the third step, we have to simplify our right hand side using property of log. Here we have log of a into b into c. So we can use first property to separate them. So using property, we can say we'll get log of a, which is cos x, plus log of b, which is log cos 2x, plus log of c, which is log cos 3x. So here we complete our second step. Now let's move to the third step, in which we have to differentiate with respect to x. So on left side we will get 1 upon y dy by dx, and on right hand side in first term we have log cos x. So we have to consider box around the cos x. So differentiation of log box will be 1 upon box into differentiation of box. Within the box we have cos x, so we have to multiply differentiation of cos x, which is minus sin x, plus to differentiate log cos 2x, we have to consider box around the cos 2x. So differentiation of log box again will be 1 upon box into d by dx of box. Within the box we have cos 2x, so differentiation of cos 2x will be minus sin 2x into coefficient of x, or we can say differentiation of 2x, which is 2, plus to differentiate log cos 3x, we have to consider box around the cos 3x. So differentiation of log box is again 1 upon box into d by dx of box. Within the box we have cos 2x, so differentiation of cos 3x is minus sin 3x into coefficient of x, which is 3. Now let's make dy by dx objective. So we can say dy by dx is equal to y into minus sin x upon cos x is simply minus tan x. In second term we will get minus 2 tan 2x, and in last term we will get minus 3 tan 3x. So tada, this is your final answer. Here we have y is equal to under root of x minus 1 into x minus 2 upon x minus 3, x minus 4 and x minus 5, which is in the first form. So let's try to solve using logarithmic differentiation. We already have y is equal to our function, so let's take log on both sides. So we'll get log y is equal to log of whole bracket raised to 1 by 2. Within the bracket we have our functions. First of all, we have log box raised to 1 by 2. So using third property, we can say this 1 by 2 power will go in multiplication of log. Now, to simplify our bracket, we have to use first and second property. This 1 by 2 will be as it is. Then log x minus 1 plus log x minus 2 minus log x minus 3 minus log x minus 4 minus log minus 5. So we complete our second step. Now let's try to differentiate our equation with respect to x. Differentiation of log y will be 1 upon y dy by dx, and this 1 by 2 will be as it is. Differentiation of log x minus 1 will be 1 upon x minus 1 into differentiation of x minus 1, which is 1, plus differentiation of log x minus 2 will be x minus 2 into differentiation of x minus 1, which is 1, then minus differentiation of log x minus 3 will be 1 upon x minus 3 into 1, and similarly differentiation of log x minus 4 will be 1 upon x minus 4 into 1, and finally differentiation of log x minus 4 will be 1 upon x minus 5 into 1. So finally we can say your dy by dx is simply y by 2, and your whole bracket will be as it is. Ta-da! Here we have y is equal to x plus 3 square, x plus 4 whole cube, and x plus 5 raised to 4. So our question is in form of 1. We already have y is equal to our function. So let's take log. So we'll get log y is equal to log of our whole function. For simplification of right hand side, first of all, we have to use first property. So we will get log x plus 3 whole square plus log of x plus 4 whole cube plus log of x plus 5 whole raised to 4. Now to simplify this, for further simplification, let's use third property, in which the power of our term can be go in the multiplication of log. Similarly, this 3 will also go in multiplication of log, and the power of last term will also go in multiplication of log. So here we get the simplified form of log 1, right? So here we complete our second step. Now let's move to the third step, in which we have to differentiate with respect to x on both sides. So differentiation of log y is 1 upon y dy by dx, and on right hand side we don't have to worry about this 2. Differentiation of log box will be 1 upon box into differentiation of x plus 3, which is 1, plus in second term your 3 will be as it is. Differentiation of log x plus 4 will be 1 upon x plus 4 into 1, and similarly in last term your 4 will be as it is, and differentiation of x plus log x plus 4 will be 1 upon x plus 5 into differentiation of x plus 5, which is 1. So finally we get dy by dx is equal to y of 2 upon x plus 3 plus 3 upon x plus 4 plus 4 upon x plus 5. Ta-da! This is your final answer. Here we have y is equal to, in this question we have to find out differentiation of log x raised to cos x, which is in second form. So we already have y is equal to our function. So our first step is take log on both sides. So we'll get log y is equal to log of log x raised to cos x. So for simplification of right hand side, let's use third property. So we can say cos x, which is in power of log x, will go in the multiplication of log x. So we'll get cos x into log of log x is equal to log 1. So here we complete our second step. Now let's move to the third step, in which we have to differentiate our equation. with respect to x. Differentiation of log y is 1 upon y dy by dx, and on right hand side सीधा से on right hand side we have cos x into log of log x, so we have to apply multiplication rule. So let's say in first step your cos x is as it is, we just focus on differentiation of log x, and for that we have to consider box around the log x. So differentiation of log box will be 1 upon box into d by dx of box. Within the box we have log x, so here we just have to multiply differentiation of log x, which is 1 upon x, plus log of log x will be as it is, we just have to multiply differentiation of cos x, which is minus sin x. So we can say your dy by dx is simply y into cos x upon x log x plus, minus sin x into log of log x. If we substitute the value of y, we will get log x whole raised to cos x is your simplest and final answer. Ta-da! Here we have y is equal to x raised to x minus 2 raised to sin x. So let's take a log both the side. Now let's simplify right hand side. So we cannot simplify our right hand side using any property of log. So in this kind of a situation, this is not a preferable operation. So in this kind of situation, let assume first step as a u and second step as a v, and we will find out differentiate individually. So let's begin with u, which is assumed as x raised to x. So now let's take log on both sides. So here we'll get log u is equal to log of x raised to x. And to simplify our right hand side, we can use third property, by which we can take this x within the multiplication of log x. So we'll get log u is equal to x log x. हाँ के ना, तो હવે differentiation કરી શકીએ. Now we can differentiate our equation with respect to x. So on left hand side we will get 1 upon u into du by dx, and on right hand side we have to apply multiplication rule, in which x will be as it is, differentiation of log x will be 1 by x, plus your log x will be as it is, we just have to differentiate x, which is 1. So in further simplification, this x will cancel out and we will get du by dx is equal to u into 1 plus log x, or if we substitute the value of u, we will get x raised to x 1 plus log x. ठीक है, ओके, अभी क्वेश्चन बाकी है मेरे दोस्तों. Now let's try to simplify our now let's try to differentiate our second term, which is v, which is 2 raised to sin x. Our v is 2 raised to sin x, which is actually in the form of constant raised to variable. So simply we have to consider box around the sin x, and we have to differentiate 2 raised to box, which is 2 raised to box log 2 into differentiation of box. Within the box we have sin x, so we just have to multiply differentiation of sin x, which is cos x. So we simply get dv by dx is equal to 2 raised to sin x into log 2 into cos x. Simple. Okay, now let's get back to our original question, in which we have y is equal to u minus b. So we can say, if we differentiate equation with respect to x, we will get dy by dx is equal to dv by dx minus dv by dx, du by dx minus dv by dx, right? So your dy by dx is combination of du by dx will come over here minus your dv by dx, put it over here. So tada, this is your final answer. Here we have y is equal to x plus x raised to x plus x raised to 1 plus 1 by x, which is third form of a question. So let's take our first function as a u and second function as a v. હવે મહેનત કરો. So let's get our u. Now let's take log both the side. So we get log u is equal to log of x plus 1 by x whole raised to x. For simplification of right hand side, let's apply third property, in which your x, which is in power, can be go in the multiplication of log. So now we should move to the third step, in which we have to differentiate our equation with respect to x. So differentiation of log u will be 1 upon u du by dx, and on right hand side your x will be as it is. We have to differentiate your log x plus 1 by x, and for that we have to consider box around the x plus 1 by x. So it will be 1 upon box into differentiation of box. Within the box we have x plus 1 by x, so we just have to multiply differentiation of x plus 1 by x. Differentiation of x will be 1 minus 1 by x square plus your log x plus 1 by x will be as it is. We just have to differentiate your x, which is 1. So we can say your du by dx is simply u into, let's say x will be as it is, and x upon x square plus 1 into, here we have to take the LCM of x square, so we get x square minus 1 upon x square plus log of x plus 1 by x. ठीक है? So your x square and x square will cancel out, and finally we will get x plus 1 by x whole raised to x into x square minus 1 upon x square plus 1 plus log of x plus 1 by x. Okay. Now it's time to get differentiation of v. It's time to get differentiation of v, which is x raised to 1 plus 1 by x. So first of all, let's take log both the side. So let's take log both the side. So log v is equal to log x whole raised to 1 plus 1 by x. Now for simplification of right hand side, we have to use the property of log. So let's use third property, in which we have to take, in which your power will go within the multiplication of log. Okay. Now we are ready for third step, in which we have to differentiate our equation with respect to x. So on left hand side we will get 1 upon v dv by dx, and on right hand side we have to apply multiplication. Pehla, in first step your 1 plus 1 by x will be as it is. Differentiation of log x will be 1 by x plus. In second step your log x will be as it is. Differentiation of 1 plus 1 by x will be 0 minus 1 upon x square. So we can say your dv by dx can be simplified as v into, here we have to take LCM of x, so we get x plus 1 upon x into x, or we can say x square. In second step we will get minus log x upon x square. So finally we can say your dv by dx is x raised to 1 plus 1 by x into x plus 1 minus log x upon x square. If we remember our original question, which is y is equal to u plus v, we have to find out dy by dx. So we just have to add du by dx and dv by dx. So first of all, let's get our du by dx plus your second term, your dv by dx. So ta-da! This is your final answer. Y is equal to log x raised to x plus x raised to log x, which is in the third form. So first term is considered as a u and second term should be considered as a v. So initially let's try to get differentiation of u. Let's take log both the side. Log u log of log x whole raised to x. So to simplify our right hand side, we are going to use third property, in using which we can take this x which is in power will be going multiplication of log. So we are ready to differentiate our equation with respect to x. Differentiation of log u is 1 upon u into du by dx. And on right hand side we have x log of log x, so we have to apply multiplication rule. Let's say if in first step your log x will be as it is. We just have to differentiate x, which is 1, plus in second step let's say your x will be as it is, and we just have to differentiate your second term, which is log of log x. So for that we have to consider box around the log x. So differentiation of log box is simply 1 upon box into d by dx of box. Within the box we have log x, so we just have to multiply differentiation of log x, which is 1 by x. So finally you will get du by dx is equal to u into log of log x plus this x will cancel out and we will get 1 upon log x, or if we substitute the value of u, you will get log x whole raised to x into log of log x plus 1 by log x. Now let's try to differentiate v, which is x raised to log x. Taking log both the sides, we will get log v is equal to log x whole raised to log x. To simplify right hand side, we have to use third property, in which this log x will go in multiplication. So here we'll get log x into log x. So we will get log v is equal to log x the whole square. So we are ready to differentiate our equation with respect to x. So on left side we will get 1 upon v d by dx is equal to, on right hand side, to differentiate log x the whole square, we have to consider box around the log x. So we just have to differentiate box square, which is 2 box into dx of box. Within the box we have log x, so we just have to multiply differentiation of log x, which is 1 by x. So simply we get dv by dx is equal to 2 times v into log x upon x, or if we substitute the value of v, we will get x raised to log x. So finally we can say your dv by dx is 2 times x raised to log x minus 1 into log x. If we recall our original question, we have y is equal to u plus v. So we can say your dy by dx is simply du by dx plus dv by dx. So our first term is your du by dx plus your second term is your dv by dx. So tada! This is your final answer. Here we have y is equal to sin x whole raised to x plus sin inverse root x, which is in the third form. So let's say your first term is u and second term is your v. So first of all, let's try to get differentiation of u, which is sin x whole raised to x. Let's take log both the side. So we'll get log u is equal to log of sin x whole raised to x. To simplify our right hand side, let's use third property, in which we can take this x within the multiplication of log. So we get our simplest log u. Now let's differentiate our whole equation with respect to x. On left hand side we will get 1 upon u du by dx, and on right hand side we have to apply multiplication rule. Let's say log sin x is as it is in first term, and we will differentiate x, which is 1, plus it's time to take x as it is and we have to differentiate log sin x. For that we have to consider box around the sin x. Yes. So differentiation of log box will be 1 upon box into differentiation of box. Within the box we have sin x, so we just have to multiply differentiation of sin x, which is cos x. So we can say your du by dx is simply u into log sin x plus x will be as it is, cos upon sine will be cot x, right? Or if we substitute the value of u, which is sin x whole raised to x, we will get simplest du by dx. Now let's get our v, which is sine inverse of root x. Your v is simply combination of sine inverse and root x. So we have to apply chain rule. Your root x is your inner function. So let's consider a box around it and differentiate with respect to x. We will get dv by dx is equal to differentiation of sine inverse box, which is 1 upon under root of 1 minus box square into d by dx of box. Our box ભરવાનો વારો. Within the box we have root x. So differentiation of root x is simply 1 upon 2 root x. So your dv by dx is simply 1 upon 2 under root of 1 minus x into x. બરોબર ને? તો સસ્તામાં પતી ગયો. જો એકમાં જ હેરાન થવાનું થયું, બીજો તો સહેલો હતો. So now it's time to recall our original question, which is y is equal to u plus v. So we can say your dy by dx is simply du by dx plus dv by dx. So your first term is your du by dx plus your second term is your dv by dx. So tada, this is your final answer.